finishing up this section with all these formulas, the last formula we're going to consider is this power reducing formula, which what we're going to be doing here, this power reducing, is taking trig functions that are in squared form, so sine squared, cos squared, or tan squared, and we're going to be able to rewrite them using trig functions that are now involving double angle. In fact, it's in all cases it's the cosine of some angle double, but now cosine in all these formulas is in the linear form. So we've gone from quadratic version of a trig function to the linear version. In this first example, we have the cosine squared of pi over 4. So using the formula, it would be this one here that says the cosine squared of some angle is equal to 1 plus the cosine of double that angle. So in this case, we have the cosine of 2, and our angle is pi over 4. So we have 2 times pi over 4, and all of this is over 2. So I just took the formula here, and for cosine of 2 theta, I put in our pi over 4 that we had. So now we have cos, 1 plus cos, 2 times pi over 4 is pi over 2, and this is all over 2. The cosine of pi over 2 is 0. So we have 1 plus 0 over 2, which is 1/2. So that's how the formula works. However, if we go back to our original statement here, we are looking at the cosine squared of pi over 4. We know the cosine of pi over 4. So the cosine of pi over 4 is equal to square root 2 over 2. We know that. This is an angle we can evaluate pretty easily. And so the cosine squared of pi over 4 would just be square root 2 over 2 squared. We know the trig function, and so now we can square it. Square root 2 squared is 2. 2 squared is 4. And this reduces to 1/2, which is the same information we got from using the formula. So to be honest with you, in an example like this, the formula isn't very helpful. What we can do, if we're looking at a trig function of some angle and we're squaring it, not the angle, we're squaring the trig function, we can just evaluate the cos or sine or tangent of the angle and then take that answer and square it. So the formula, not so useful when we're given the angle. However, where this formula is very helpful is if we are given information where we don't have an exact angle. So in this particular example, we're looking at sine to the 4 of x. Our angle here is x. It's a variable. We don't know what it is. And this example is one that really shows the benefit of this formula. I mean, we're just going to use the formula and then stop when we get our answer. But those of you that go on to take calculus or might have seen calculus will come to really appreciate this formula. In fact, it's going to save your life in some instances where you're looking to integrate in calculus and you're looking to integrate a trig function and you're not able to touch it because the power of it is quadratic or something greater, and you have to be able to knock it down to its linear form. This power-reducing formula is what's going to save the day for you. So going back to this particular example, we're looking at the sine of x to the 4th power. And we want to get this down so that, as it says, the trig functions are no greater than 1. So we want to get it down into linear form. Our formula deals with the sine squared, not sine to the 4th. So the first thing that we have to do is consider that sine to the 4, we can think about it as sine squared squared. That will give us our sine to the 4th power. And the reason why this is beneficial is we can go and we can take our power reducing formula. So going back to this sheet here, for sine squared, it's 1 minus the cosine of 2 theta over 2. So this is going to be 1 minus the cosine of 2 theta. In this case, our angle is x, so it's cosine of 2x. And now this is all over 2. So this here has been rewritten like this. We've used the formula to go from here to here. Now, this is still to the power of 2. So we have to put the power of 2 to this expression here. Remember, what this means is 1 minus the cosine of 2x over 2 times 1 minus cosine 2x over 2. So we're going to expand this statement using this multiplication to proceed with our example. So here, I'll do the denominator first since that's easy. 2 times 2 is 4, so we have a nice 4 in the denominator. And now we have to FOIL this multiplication here. So 1 times 1 is 1. 1 times negative cosine 2x is negative cosine 2x. Inner negative cosine 2x times 1 is negative cosine 2x. So that gives us negative 2 cosine 2x. And last but not least, negative cos 2x times negative cos 2x. Negative, negative, we get positive cosine squared 2x. Cosine squared 2x. We are not where we want to be because we still have an exponent of 2. So in order to deal with this, we're going to have to break this expression down into 3 separate fractions to isolate this. Well, we could deal with it up here, but it'll make the numerator much more complicated than we need it to be. So I'm going to break this down into 3 fractions. 1 over 4. Then this next one, negative cosine 2x over 4. And then plus cosine squared 2x over 4. So just taking this one numerator and breaking it into the 3 pieces to create 2 fractions. So here I'm seeing this, so I'm going to deal with this just because I'm seeing it and I want to simplify it before I forget. This 2 and this 4 we can simplify here. So this would be cos 2x over 2. Now coming here, this here, because of this, we're going to reduce this again. So we're going to have to do another reduction in this problem. And this here, cosine squared 2x, now we're going to use this formula here, which says cosine, well, we used it already, but I'll just show you again. Cosine squared is 1 plus cosine 2 theta over 2. So this here is going to be 1 plus cosine of 2, and now our angle is already 2x, so we're going to be multiplying by 2 the 2x we already have, and this is all over 2. So I'm just taking this and reducing it here. So let's go back. We have 1 over 4 from here. We've reduced this, so it's minus cos 2x over 2. And now over here, we have 1 plus, in our numerator, it's now 1 plus cosine 2 times 2x. So 1 plus the cosine of 4x. 2 times 2x is 4x. And in our denominator, we had the 4. So we already had that 4, and now we're going to multiply it by 2. So this is going to become 8, but I wanted you to show you we have that 4. When we replace this by this, now we have the 4 and the 2 in the denominator. So this now will be 8. So we have 1 over 4 minus cosine 2x over 2 plus 1 plus cosine 4x all over 8. Oh, I got to remember to look up at the screen so I don't lose the paper. Last but not least, just like we broke up this fraction up here, we're going to break this one up. So we have 1 over 4 minus cosine 2x over 2, and now we have 1 over 8 plus cosine 4x over 8. And taking a look at this and this can be combined. So 1/4, this would be the same as if we make this denominator 8, this is the same as 2 over 8. So we can combine these 2/8 and 1/8. So we have 3/8 minus cosine 2x over 2 plus cosine 4x over 8. Just, oh, by the way, we cannot do any reducing this 2 in the cosine 2x and this 2 because this 2 in the numerator is locked into that trig function. We are not allowed to cancel with anything in the denominator. Same thing here. Can't cancel that 4 and that 8 because that 4 is locked into the cosine function and not available to be canceled with anything in the denominator. So this would be our final answer. And as I said, for our purposes, this is where we're going to take it. In calculus, trust me, you will be very happy that you have this formula available to you.